Hey everyone. So today we're going to start probability. So let's get into it. So I hope you would be knowing what probability is actually, but let me take a quick revision for you. Okay. So what probability is actually is okay. So probability is nothing but how likely how likely something to happen and assigning signing a number to it. Okay. Yeah. So we all are well known with the probability, what it is and how and where do we use it. It deals with chances, likelihood, something that is to happen, and what is will be next or something. So we all know that. Okay. And what actually it is that it is nothing but the how likely something is to happen, and assigning a number to it. It's that simple as possible. Okay, I'm keeping it as possible. It's as simple as possible because this is actually a basics lecture, so that's why. Now moving to the next one, what we have is that sample. Okay, let me fix the spelling of m. Yeah, we have the sample space. Okay, we have the sample space. We should be must be aware with the sample space that what it is actually. Okay, so sample space is nothing but it is the list of all the possible outcome that are possible to come. Yeah, it is the list of what I would say. It is the list of all the possible outcomes. Okay, and we write it in the form of a set. Okay, what it is set actually, it's nothing but it is a form of listing things in a, I would say, take it as a suppose that this is a container. Okay, and we are just using it to keep things. Okay, and like that set is actually a kind of, we could say that storing numbers. Okay, just understand that it is nothing but to store the number. Okay, it is something that stores number. Okay, now we write it in a set. Suppose that we are rolling a dice. Okay, we are rolling a dice. What are its possible outcome? 1, 2, 3, 4, 5, and 6. These all are the outcome that are actually possible in the dice. Okay, there won't be a 7, there won't be a 8 in a dice. If it is an if it is an unique dice, then it could be, but generally we have only 6 outcomes which are possible outcomes there. Okay, so sample space, as I've told, is nothing but it is the list of all the possible outcomes. Now we have another thing which we called is an event. Okay, what we call an event, and what an event is that it is the subset of us subset of the sample space. Okay, subset of the sample space. We actually denote it with the s. Okay, we denote the sample space with s. So it is the subset of the sample space which has a possible outcome. Okay, which has a possible outcome from the sample space. So what I'm trying to say here is that event is a possible outcome from the sample space, and the sample space is the list of all the possible outcomes. So the event is actually a part of sample space. Okay, it is actually part of sample space. If we visualize it, so it will be like this. So we have a box. Okay, we have a box here, and this is what we call is s for sample space. Okay, sample space, and we have a point or dot that what actually is an event. Okay, is an event. Okay, so this is what it. So let me take to you an example of rolling a dice. Okay, so suppose that we roll a dice. Okay, we roll a dice and we have the possible outcomes as 1, 2, 3, 4, 5, 6. Okay, this is our the all the possible outcomes. Now we have an event A, and what it says that the outcome. Okay, that it says that the outcome that this event will give us will be 1. Okay, 1. So there is an event which says that it will give us the outcome of 1. Okay, now we have to find the probability of that event A, that what is the probability of getting event A in the whole sample space. Okay, so it will be nothing but what it will be, probability of A getting A, which will be nothing but A by 6, because we have only the 6 possible outcomes, 1 2 3 4 5 6. We have the 6 possible outcomes. Okay, we have one, but it will nothing but 1 by 6. Okay, and for all the number in it. Okay, so 1 by 6 will be for all, for probability of getting 1, probability of getting 2, and so on till the probability of getting 6. So it will be same for us. Okay, it will be always be same for us. Now we can have a event which can be getting a which can be a filtering out event, can be also what it will be look like that. Suppose that we have an event B, and it says that the only number it will get will be greater than 4, will be greater than 4. So in the sample space, let's find the number which are greater than 4, which are nothing but 5 and 6. So this event says that it will only contain number that are greater than 4, which is nothing but 5 and 6. Now what is the probability of getting event B? It will nothing but 2 by 6. Why? Because we have only 2 possible outcomes of the event B, and divided by all the possible outcomes. Okay, so it will nothing but 1 by 3. So you know that. Okay, I know you know that, but it was just a quick revision. Now moving ahead, we have some more important things. Now we have to put now we have to put our events together. Okay, putting events together. Okay, now we can put our events together in two ways. Okay, the first one is union, and the second one is intersection. The second one is intersection. Now, what union and intersection is, let's find it for now. So first we'll go with our union, what it is. So to put two events, okay, together, okay, or it's actually, if you talk about in the perspective of union and intersection, what it is actually, then it actually don't work in probability or events. It actually works in the sets. Okay, so it will be better to call us not to put events together, but to put sets together. But to put sets together. Okay, and what a set is nothing but, okay, if an event has a set of this like 1, 2, and 3, so this set equals to A or A equals to this. So if we saying that if we have to put A together, then we can also say that we are putting events together. Okay, yeah, but in the terms of layman terms for understanding the union and intersection, so it basically it actually work in the sets. Okay, so it won't be, but still I did it. Okay. Yeah, so what is in to put union in? Okay, put two sets together into one possible outcome. Okay, possibly larger set is called forming a union. Okay, union of two sets or more sets. Okay, two or more sets. Okay, yeah. So what we have that, and how do we represent it? We represent it by A union B. So we use actually this symbol, not U. It is not actually U. It is like this. Okay, like this. You could say U, but union. It is actually union or U. You could say that. Now let's take an example. Okay, of rolling a dice. Our favorite, rolling a die. Now we have an event A which says the outcome it will give. Okay, the outcome in this event will be an odd number. Okay, which will be 1 3 5. As you know, from the set of 1 2 3 4 5 6, we have only three odd numbers. Okay, we have only three odd numbers, 1, 3, and 5. So we have assigned this to our first the set of A. Okay, this. Now we have another event which says greater than 2, greater than 2, and let's find out which are the numbers in what are the possible outcomes that are greater than 2, which are 2. 2 won't be, but it should be greater than 2. Then it will be 3, 4, 5, 6. These four number are greater than 2. Okay, so what will the set of it? What? 1? It will be 1? No, it will contain 3, 4, 5, 6, because they are greater than 2, obviously. Now what will be the union of it? Okay, we have to find what will be the union of it. And what does union means? That we have to form the larger set of getting a possible outcome. Larger set means including this and including this, we have to include the both sets. Okay, we have to include the both sets that which are in it. Okay, we have to just add two sets. Okay, so it will be union, it will be. Okay, now we have to find all the outcome that we can get. Okay, so let me choose another marker. Yes, yeah, this is. So we have 1 here, so in the set we'll add 1. We have 3 here also, 3 here also, so we will only add ones for the both. We'll only add ones for the both. 3, we have 5, we have 5 here, and we don't have 4, but we have 4 here, but we still add it because it is a union. Okay, from your side and from my side, we will use a both side. Okay, so it looks like that. uh Union look like this, looks like, if we actually visualize this, then it looks like this. Wait, why? Okay, so if I copy this, copy and paste. Yes, we did it very rightly. Yes, so yeah, union means this. So we have event A and event B, so containing both, including both. Okay, what we call is a union. Okay, now, so moving ahead, we will add 1, 3, and 5 and 4 also, because it is a union actually. So I'm using yours and you're using mine. Okay, all the resources we have, we are using both. We can use both. Okay, both resources. So it has 1, it has 3, it has 4, it has 5, it has 6. Okay, and remember that we have only used ones which have occurred twice. 3 and 3 here, here it is 3, 2 threes, but we have only used once, because how can we have get, we cannot have three two threes in a dice. Okay, we have only 1, 2, 3, 4, 5, 6. We don't have twice 3. Okay, we don't have 2 threes, we have only 1 3. Okay, this looks like this. Now another, we have intersection, and this is actually something that reduces things. Okay, intersection. So two, so intersection, in the intersection, what we do actually here is that we only find those number which are actually common in the both sides. Yeah, exactly what you're thinking, which are common in both sets. Okay, so how do we represent the intersection? This, yes, you know, just opposite u. Okay, I would say not opposite, but um flipped u, you could say that. So it will be nothing but, so whatever event 1 says, that event A says it only odd numbers, and event B says greater than 2. So now what is the intersection of A intersection B? So we have we have to only find that are common in it. So let's see which numbers are common in it. Okay, so we have 3, we have 5, we have 3, we have 5. Now there is nothing common in it. You have only two numbers that are common, 1 4 no, 1 6 no. So we have to only find that we that that are common in the both sets. Okay, so in the union, what we did, we actually expanded our set, but in the intersection, what we did, we filtered out, and we only uh, added the number which are actually common in the both sets. So it's simple as that. Okay, simple as that. So what we'll do, we'll give it one, sorry, not one, that's my mistake, 3 and 5. So this is the intersection of set of A and B. Okay, now we have another, suppose that we have another event which says that only even numbers, even numbers. Okay, so what will be the possible outcomes? 2, 4 and 6. Now we have to find the intersection between, not n, intersection between A and B, which will be, suppose what it will be, nothing, zero, not even zero, zero, not even this set, it's wrong, it's zero, there is nothing any common between them. How can we, add the both? Okay, now we have, and what will the uh okay, so we are done with this, we are done with this. Now what will be the union of A and C? Nothing but 1, 2, 3, because we have to expand, we don't have to filter out and get that are common. Okay, now moving to next. So we have uh next things which we have here is finding the probability. Okay, finding the probability of the union and the intersection probability. Okay, the union and the intersection of probability. Now, so we have to find the union probabilities for the union. Okay, so what we will do here is, okay, so A, let me write it. Okay, okay, so what I did here is actually is that I got two events, and the event A says that the possible number will be even. Okay, and what is the even number? 246. Simple. Now we have another event which says that the number is less than 4. Less than 4. So what is the number that are less than 4? 1, 2, 3. Now we did the union of this set, which is 1, 2, 3, 4, 6. Okay, this is union. Now we have to find the probability of that union. So probability of that union, that what is the probability that these number will come. So what are the outcome that we want? 1, 2, 3, 4, 5. We have 5 numbers. Okay, or the 5 outcome that we want. So it will be 5 by 6. Simple. Okay, so we got our union probability. Okay, now what this union probability says, so we have to keep this in mind, that union probability says that either A or B or or both. If you look very closely, okay, very closely, let me zoom it out for you. We have 246, 246. That is actually this set. Okay, so we are getting the probability for the event A and the B also, either for event A or for B or for both. Okay, so the union probability tell us the the probability of A, event A, event B, or both. Okay, got it? Yeah. So what our union probability tells, the probability of either A, B, or for both. How? We have included both, or for B. See, this satisfies both sets. Okay, 1, 2. Are we getting 2, 4, 6? Yes. 2, 2, 4, 6. Are we getting 2, 4, 6? Yes, definitely. 2, 4, 6. So this satisfies this set also. Are we getting 1, 2, 3? Yes, 1, 2, 3. And this set is also getting satisfied. See? So that's why this tells us the probability of both event, okay, for either A or B. So it tells us A, B, or both. So that the union probability tells us. Now moving to next one, which is the joint probability, which is the most used probability in the ML. Yes, one of the most important probability. So let us understand it. Okay, what it is? It's nothing, but we have to understand it. Okay. Yeah. So, what the joint probability tells us that it tells that the what is the probability of the events happening at the same time. Okay, we have two events, and what is the probability that both event will happen at the same time? Okay, and understand with an example. So we have an example in which we have event A says even, okay, even numbers, and event B says less than 4. Okay, so what are the sets for it? For this, we have a set of 1, 2, 3. For this, we have set of 2, 4, 6. Now, what is the A intersection B here? Okay, what is the A intersection B? We have to find only the common ones. Okay, so is there any common thing? Yeah, 2. We have 2. So this is this the set of A intersection B only contain 2. Okay, now what is the probability of A intersection B? It is nothing but 1 by 6. What is A intersection B? Getting the probability of 2. Getting probability of 2, which is 1 by 6. Okay, 1 by 6. It's that simple. So the joint probability tells us that what is the probability of events happening at the same time. Happening at the same time means that what is the intersection of both sets. Okay, what are the common outcomes in the both sets that will come at once. Okay, if we have both common between us, then if two things, okay, understand it, if two things are common uh, in the both sets, okay, then the probability of getting that outcome, okay, will be also same, because there will be, see, there will be one, there will, oh sorry, two, we have two, so we have two in the event A also and the two in the event B also. Okay, so if two comes, then the both events get satisfied that it is even. Okay, and what joint probability says that and, okay, in the union probability, okay, what we have that either A or B, but in the joint probability we have A and B. We have to satisfy A and B also, that it should be uh, even number, and it should be less than 4. Okay, and the both condition satisfy when we have the 2. This satisfy the both condition that uh, it is even and it is even less than 4. Okay, so I hope that you would have understand, and I am going to wrap this up. So thanks for watching till right now, and if you want know more resources and you want to know about more the thing, and we you want to connect with me, you can go and check our Discord link given in the description. So yeah, thanks for watching till right now. Bye bye.